Hello, this is our lab reports for heatsink simulation and comparison. I will be the one to introduce my group's members, which is 1. Won-Chung-Wai, 2. MOIRA PATERUS, 3. Jeremiah DARSHAN, and me, Muhammad FARIS ATIQ. Heatsink is a component that transfers the heat from any device to the cold side and prevent overheating. The heat is carried from the bottom or base of the structure and through conduction, and carry the heat to the cold side and perform heat transfer. Heatsink is required on many designs such as CPU. The CPU without the heatsink will be overheated and burned, so the heatsink is one of the most important components to absorb heat from it.
Hello guys, my name is Wong. I'll be doing the sketches for the heatsink here, as you can see. So the next thing, we are going to make the shape for this heatsink. So overall, this is the heatsink, one of the heatsink I created. The standard size is 40 times 40, and these are my other designs too. Design number 2, and this is one of the design 2. So in total I have 3 heatsink I'll be comparing. So here's for the design we have just made. So I have applied the hot side with the temperature for 97.3 Celsius and the temperature for the cold side for 76.6 Celsius. The heat flux for the whole thing for the cold side is 1500 volts per meters cube, and for the convection efficiency for the whole thing is 5.03. The ambient temperature is 303 Kelvin. So after we key in the data, we can run the study. So this is the study for the heatsink. So after creating the 3 of the heatsink, the similarity will be the material, which is alloy steel, and the similarity will be the base, which is 40 mm times 40 mm. So we'll be going to heatsink number 1. As you can see, it is with medium height among heatsink 1, 2, 3, and the design is made with an arc, so it's a little bit arc shape, and it's really thin. The mass will be 0.0836 kg, and the density of the alloy is 7,700 kg meter cube. Thus we can see it's made by alloy steel, and the thermal conductivity is 50 volts, and the specific heat is 460 joule, and this is the design for heatsink number 1. So this is heatsink number 2. It has the weight of 1.47191 Newton. So this is the heaviest among all the heatsink. It has a really long shape, and it has like a vase shaped design, and it's really thick. So the third one is heatsink number 3. This one is like a fan shaped design, and it's short and thick. So it has the mass of 0.847 Newton. So this is not the heaviest. So the heaviest is heatsink number 2.
Hello, my name is Mara Petrus. For thermal load, for temperature 1, we apply 97.3 Celsius to the hot side, and then 7 to 76.6 Celsius to the cold side, and the heat flux is 1500 watts per meter square to the cold side, and then 5.03 watts per meter square Kelvin for the convection coefficient, and then the bulk temperature is 303 Kelvin. The next one is the result for heatsink 1. The minimum temperature for this heatsink 1 is 3.498 Kelvin, and for the max is 3.705 Kelvin with the nodes 1548. And then for the result for heatsink 2 is the minimum temperature is 3.498 exponent -02 Kelvin with a node of 1, and then the maximum temperature is 3.705 exponent -02 Kelvin. And then for the result for heatsink 3, the minimum temperature is 3.498 exponent -0.2 Kelvin, and then the maximum is 3.705 with the nodes of 9. From the result that we have taken, so the heatsink number 2 is the best design because it has a higher integral shape like vase, having the best conduction and heat transfer. Due to the bigger the size, the better the transfer of heat. For heatsink number 1, it can perform the heat transfer fairly with the arc shape and thin, and the big gap in between, those creating a good heat transfer. For heatsink number 3, it is not the best heatsink due to the short body. And that's all for my part. Thank you.
A very good day. My name is DARSHAN and I'm lucky ERUTHAYA SOOSAY. My ID number is B092010-370, and today I would like to present on the conclusion for our heat transfer assignment. So for the first point is, in this assignment we learned that the bigger the heatsink, the more steadily it can dissipate heat. It's because the bigger the surface area, the better dissipation of heat through the heatsink. And for point number 2, heatsink 2 is the best among the two following by heatsink 1 and heatsink 3. It's because the fins are based on the size, the convection coefficient, and also the temperature, which affects. For point number 3, alloy steel may not be the best heat conductor for the heatsink. It is because that alloy steel is not a good conductor of heat. Point number 4, alloy steel holding value of heat conductivity of 45 watts per meter Kelvin, while aluminium holds a value of heat conductivity of 247 watts per meter Kelvin. And for the last point, the fifth point for the conclusion, heatsink can be improved by choosing alternative material or better design. Changing the materials such as copper, as it has better conduction of heat, and also a better design which depends on the shape and size. That is all for my presentation. Thank you.